Welcome back to the another video on concepts of power electronics. So in this particular video we will talk about what is AC to DC converter. Okay, so what is AC to DC converter? So AC to DC converter is nothing but the rectifier which actually converts your alternating current AC quantity AC current which periodically reverse direction into the direct current which flows in only one direction. This conversion is essential in many applications where DC power is required, such as in power supplies for electronic devices, battery charging, and more. So, what I want to say basically graphically, so if I have my sinusoidal AC supply available, I can convert it into the some DC direct basically current supply which sometime we required. There are many applications we will see where we need DC supply for that application. Talked about our mobile phone charger. Mobile phone charger need DC power supply. But what comes to our houses? We receive 230 volt RMS to our house which is in AC quantity having the frequency of 50 hertz. So we need to convert it. So that is why this circuitry is used. This circuitry is called as a AC to DC converter, also we called as a rectifier. Okay, so how we will convert it? So there are basically the different types of AC to DC converters available in the market. So depending on our requirement we will use simple one, complex one. So what are the different types of the converter available? So we have half wave rectifier, we have full wave rectifier, we have bridge rectifier. Okay, so there are the various types of DC to AC to DC converter available. I am not going too much of detail about what are the different types of this rectifier, how their operation will be happen and all, how the circuit looks and all. I will just briefly go through the half wave rectifier, that how this circuit is available and how exactly it converts the AC quantity to DC quantity. So let's talk about the half wave rectifier. So this is kind of circuit I have. This is my transformer. Why this is a need of transformer? Because I am getting here 230 volt RMS, right? I need some time for my circuit. My application requirement is not that much. I need maybe 100 volt. So I can step down the voltage from 230 volt to 100 volt and then I can use it. So this circuit you are seeing, one diode and one load, this basic circuit is called as a half wave rectifier. So you can see one simplified circuit. So I have my AC supply available, one diode is available. Diode is a power electronic switch. We can have some different depending on our output requirement, we can change the diode with some other power electronics device like thyristor, MOSFET, IGBT. So we can use some different device as well, but this is a basic half wave rectifier circuit. So what is this AC supply? This is my sinusoidal supply which I am going to give here. What output I am expecting? I need the DC output, one constant output which I can use. Now exactly how it converts? So you should know about the operation of the diode. So diode basically, when simple, if I wanted to talk about, when the supply voltage is greater than its cut-in voltage, that time it will be in the forward biased, so it will act as a short circuit. When supply voltage is less than its cut-in voltage of the diode, it is in the reverse bias, and in the reverse bias what is happen, it is act as a open circuit. So let's talk about positive half cycle of the input voltage. So this is the circuit. So my diode is short circuited. So if I simply apply the KVL, what I am going to get? V out is equals to V in. Now many people confused here. V out equal to V in. You looks V in is a positive. So you may think that basically this is positive half cycle. Okay. But sometime what happen in negative half cycle also we will get V out equal to V in. That time you should understand one thing, that V out equal to V in is not the positive. It is depend upon the which input cycle I have. I wanted to say, I will just show you, this is my input cycle. Okay, So if I am getting in this particular V out equal to V in, V out equal to V in means I will follow the same route whatever here. Okay. Second thing, if I am getting in negative half cycle V out equal to V in, I will follow this. I will follow this, whatever the nature of this, I will follow it. Right. Second thing again I wanted to say, if in this a particular half I will get V out equal to V, then I will follow it. Okay, but here if I am getting now V out equal to minus of V in, then I will change my direction. I will change my direction, meaning if it is in negative direction, V out equal to minus of V in, I am getting minus of V in does not mean it is going in negative direction. It is minus of this, so it is already minus, so I will be taking this route, right? So this is what I wanted to say. So is it fine here that during the positive half cycle V out equal to V in, so I am going to get this kind of nature. So second thing, during the negative half cycle, my diode will be in the reverse bias, so it will be act as a open circuit. That time no current will flow through the circuit, so definitely output will be 0. So what is my waveform? So I have told you this thing. I have my sinusoidal AC supply input available. Now at when initially at first half I am getting the output, second half I am not getting any output. First cycle is completed, then again during positive half cycle I am going to get my output, then again 0, then I am going to get output. But if you see this output, it is not looking like a sinusoidal, it is not looking like a DC. What output I am expecting? I am expecting this kind of output. I want some constant output. If I am getting constant output, then only I can supply it to the DC, then only I can use it as a DC power source, and I can give the constant DC to some applications, right? But this is not there. Then what should I do to get my constant DC? So simple solution, add the capacitor in front of the load. So if I add one capacitor in front of the load, then I will get a constant output. So what I just have to add, I will going to add one capacitor here. Capacitor will charge, discharge, and basically I am going to get one constant output. So that time what will happen, when I apply the sinusoidal input, I am going to get such a constant output. So this is all about, this is how AC to DC converter work. It is called as a rectifier, and this is how it works, and we will get the one constant DC power source, and which we will use as a source, and we can give it to some other system, right? So I hope so you understood this. Now we will see some applications of AC to DC converters. So in consumer electronics, talking about the mobile chargers and laptops, I have already told you, there we will use. Second thing, in televisions, so if you see the modern television, they use the DC source as an input, so there we will use. Third is the electric vehicle charging. If you see, so battery charging, battery is a DC, so I need the DC power supply. Then if you talked about the renewable energy system, so that time solar energy, wind energy, there also I need a DC input as a source. And some other applications are there like telecommunication industry, data centers, medical devices, household application, n number of applications we are using where a DC power supply requires. Then electric motor drives, DC motor drive are there who needs the DC supply, so that time we require the DC power supply, so we have to convert from rectifier AC to DC converter, then we will use that DC to some other thing. So I hope so you have enjoyed this video. What is rectifier, what are the applications of rectifier, how a basic half wave rectifier work, you have learned this concept. So now this is all about this video. So thank you, stay tuned for the next video, and if you want me to improve something, please comment and subscribe to my channel. So thank you.